Hello everyone, how are you all? All are fine? Okay, today we will discuss a new chapter which is solutions and colligative property, which is important point of view of NEET as well as JEE mains as well as JEE advanced. So solutions and colligative properties are not a very big chapter, small chapter. Basically, this is a little bit related with concentration term, which is basically class 11 topic. Basically, molality, normality, this term will always appear in this chapter. So just write down the chapter name, which is solutions and colligative property. The chapter name. Chapter 2 in your class 12 syllabus. Okay. Now, solution and colligative property, what part we have to learn? First, concentration term. Second, Vapour pressure. Third, Vant Hoff factor. Fourth, colligative property. Colligative properties. Now, in colligative properties, four colligative properties are there. First is RLVP. What is RLVP? Relative lowering of vapor pressure. Second is elevation of boiling point. Third is depression of freezing point. And fourth is osmotic pressure. Okay. And the last part, next is solubility of gas. So basically, this five part we have to learn. Now today we will start from concentration term, or what is first we will do what is solution, what is solute, what is solvent. Then we will do what is concentration term. So just write down next part, which is solution. Now, what do you mean by solution? Solution is a homogeneous mixture. Now, what is the difference between homogeneous mixture and heterogeneous mixture? For homogeneous mixture, mixture particles, suppose two substance or three substance mix each other and form a homogeneous mixture. Now, in the mixture A, B, C, three component you cannot separate in your own eye, or you cannot see in your own eye. These are called homogeneous mixture. Like as when some amount of salt, if you put in water, now it is easily dissolved. Now in a after taking solution, you cannot see the salt particle in your own eye. These are called actually homogeneous mixture. Homogeneous mixture are the mixture but the particle component you cannot see in your own eye. But for heterogeneous mixture, suppose if you put some amount of mud in a water, you can easily see the mud. These are called heterogeneous mixture. Okay, so just write down solution. Solution is a homogeneous mixture. So the next part, what is solution? Definition: a solution is a homogeneous mixture. Homogeneous mixture of two or more than two substances. in which individual component will lose their identity, and cannot be separated in pure form by the simple method. So that is about solution. Now, if you go for the solution, what is the classification of solution? You can easily classify it into two parts. One is solute, another is a solvent. You all know that this is at class 9-10 level, solute and solvent. Now, what is solvent and what is solute? Solute case, remember lesser amount or less amount present or smaller amount present. And for solvent case, larger amount. Okay. Now, suppose in your example, what is given? 40% ethanol. What is the meaning of 40% ethanol? 40 ml ethanol, ETOH, which represent ethanol, and 60 ml, 100 minus 40, that means 60 ml is water. Now, tell me in which case this amount is high. So, this one acts as a solvent. This one acts as a solute. Okay. Is it clear? Now, if you write down like this way, 60%, this is the first example. Second example, 60% ethanol. In this case, can I write 60 ml of ETOH present plus 40 ml of water? Now, this amount is a lesser amount. That's why this one acts as a solute. This one acts as a solvent. Is it clear? Any doubt? Do you have any doubt? Okay. Moving to the next part. Next part is the concentration term. What are the concentration term? Next part, concentration term. Okay. Now, concentration term, if you write down the concentration term, it can classify into two parts. It can easily classified into two parts. That is a group A and another is a group B category. Group B category. Now, for group A category, this is basically volume related term. Volume related. And this one is mass related term. Now, mass related term, which is basically temperature independent. TMP represent temperature, here temperature dependent term. Okay. Now, if you go for the brief classification, which part under group A, which part under group B, how can you write? First part, we can write percent by volume. Second, percent weight by volume. That means first one you can write like this way, volume by volume percentage. In this case, you can write weight by volume percentage. Now, what is weight by volume? What is volume by volume? That we will discuss. Don't worry. Okay. Third one, molarity. And fourth one, normality. Now, if you go for classification for group B, first is percent by mass. Percent by mass means basically weight by weight percentage. Next one is mole fraction. Third one is molality. Fourth one is parts per million. That means ppm. Okay. Is it clear? That is about group A and group B. Group A, which represent temperature dependent. Basically, in this case, volume term is introduced. But if you go for the group B stuff, which is temperature independent, no volume term. Basically, here mass term is present. Now, we all know that mass is not dependent with temperature. If you increase the temperature, decrease the temperature, what is, suppose my weight is 50 kilo or 70 kilo. Okay. Now, if I suppose today in the air temperature is little bit less, little bit cool because due to rainy day here. So suppose today's temperature is 25 degrees centigrade. Now tomorrow or day after tomorrow it becomes 40 degrees centigrade. My weight 70 to 72, 70 to 69. Is it possible? Not possible. That's why mass is also temperature independent term. So basically this concentration term, that means group B, which are temperature independent. Temperature independent means in this case mass is present, nothing else. And in this case, for group A case, temperature dependent means in this case volume is present. Okay. So just next part we are moving group A. First we'll deal with the group A part. Group A means percent weight by volume, volume by volume, molarity, and last is normality. Normality stuff we will discuss later. Normality is not a very much important for this chapter. Okay. Now next, moving to the next part. Part number group A. Under group A, first part is weight by volume percent. Just write down volume by volume percent first. Volume by volume percent. Or you can write percentage by volume. Now, what is the meaning of that? Meaning of that is basically if you write down volume by volume percent. What is the meaning of that? Always remember, percentage means 100 is present. The upper part is always solute. The lower part represents solution. Okay. Is it clear? So V solute basically volume of solute. V solute which represent volume of solute. V solution which represent volume of solution. Okay. Now always we all know that solution which is basically solute plus solvent. Okay. So volume of solute which is equals to volume of solution. This stuff is solution. Volume of solution which is equals to volume of solute plus volume of solvent. Example, if you write down the example, 30 weight by weight percent or volume by volume percent of HCl. What is the meaning of that? Volume of HCl which is 30 ml, you can write 30 liter also. Volume of solution This represents solution, okay, which is 100 ml. Any doubt? Any doubt? Do you have any doubt? So this is about the first part. I am giving you one question. Try to solve it regarding this part. Question number 1. How much ml of ETOH should be added in 250 ml of water to obtain a solution containing 80 volume by volume percent of solvent. Solve it quickly. Done. Now, what is the meaning of this one? 80 volume by volume percent of solvent. So, volume of solvent which is given 80 ml. Now, what is the volume of solute? Volume of solute you can write, that is 100 minus 80, that means 20 ml. Now, go for the formula. What is the formula? You can write 20 equals to V plus 250. What is 250? This 250 is basically this one, okay, 250 into 100. Now from here you can find the V value. From here if you calculate V plus 250, which is equals to 5V, so 4V which is equals to 250, so volume equals to 62.5. Is it clear? Is it clear? So this is about the first question. Any doubt regarding this part? First concentration term completed. Next we are dealing to the next concentration term, which is weight by volume. Weight by volume percentage. Now what is the meaning of weight by volume percentage? If you write down this one, weight by volume percentage, percentage of weight by volume, which is equals to, always remember the upper one is solute, the lower one is also always solution. So 100 is also present. Now upper one is always solute, that means weight of solute. This one represents volume of solution. Okay. Now in your question, in your example, if you go for the example, suppose this one is given 30 weight by volume percentage of urea. What is the meaning of that? What is the meaning of that? We can write 30 gram of urea dissolved in 100 ml of solution. Okay, so basically here weight of urea, weight of solute means urea here, which is given 30 gram, and volume of solution, which is given 100 ml. Now density of solution, which is suppose like 1.2 gram per ml. Now what will be the weight of solution? We all know that density equals to volume. Now what is the density into volume, which is basically weight? So can I write weight of solution equals to volume of solution into density of solution? Now 100 into 1.2, that means 120 gram. This is the weight of solution. Weight of solute is given 30 gram. Now what is the weight of solvent? Weight of solvent, which becomes 90 gram. How? 120 minus 30 equals to 90. Is it clear? Do you have any doubt regarding this part? So this is about the second concentration term, which is under group A. Now we are moving to third concentration term, one of the most important concentration term, which is molarity. Third one. Molarity. In short, you can write capital M. Molarity can be considered as a molar solution, like this way. Molar solution. Molar solution term is given means molarity is given in your question. Now, what is the meaning of molarity? Molarity is basically number of moles of solute. Number of moles of solute present in 1 liter of solution. Okay, this is about molarity. Okay, so in short, we can write molarity equals to number of moles in volume in liters. Okay, in some cases, suppose semi-molar solution is given. Semi-molar. What is the meaning of semi-molar? Here, molarity equals to m by 2. That means 0.5. Okay. Is it clear? So basically, always remember this part. Semi-molar, which represent m by 2, which is 0.05. Now another term, dimality. What do you mean by dimality? Dimality is also molarity. Number of moles of solute present in 1 liter of solvent, but at 0 degree centigrade temperature. Now at 0 degree centigrade temperature, what will be the molarity, which is represent this molarity term, which is changes to dimality. Okay. So dimality. Number of moles of solute present in 1 liter of solution at 0 degree centigrade. Okay, this is called dimality. Any doubt? Now, how can you find? How can you find number of moles? How can you find? Suppose this one is the moles. Here, number of particles is given. Volume of gas. And here given moles. Okay. Now, given mass to moles. That means mass is given mass is given to you. Now you have to find moles. How can you find moles? You have to divide it by mm. Mm represent molar mass. Here mm represent molar mass of that solute. So always remember, when something is given, suppose molar mass, number of particles, volume of gas, whatever is given, always it will convert it to moles, means always divide. Always divide. Remember this part, always division. And moles to anything, always multiplication. Always multiplication. Is it clear? Okay. Now, moles is given, you have to find given mass, you have to multiply it by m, which is molar mass. Moles to number of particles, you have to multiply it by Na represent Avogadro number. Okay. Moles to volume of gas, you have to divide it by 22.4 liters. You have to divide it by 22.4 liters. Volume of gas to moles, you have to divide it by 22.4. Moles to volume of gas means multiplication. 22.4. Is it clear? So basically something is given to you. It can be volume of given mass, it can be number of particles, it can be volume of gas. You have to convert it to moles, means always divide it. Okay. Okay. Always when you convert it to moles means always divided. Moles to anything means always multiplication. Remember this part. Moles to anything, multiplication, anything to moles, always divided. Is it clear? Where Na represent basically Na, which is Avogadro number. You all know the Avogadro number term, which is 6.023 into 10 to the power 23. Okay, and important this stuff you have to read. Is it clear? Now I am giving you just one question regarding molarity. Then we are going to the molarity of dilutions, molarity of mixing, whatever stuff present that we will discuss. Okay. So just write down the questions. Next question. 30 gram of urea. What is the urea? We all know that CONH2 whole 2. This is about urea. Is dissolved in sufficient water to produce 2 liters of solution. Now determine first what will be the weight by volume percentage. Second, what will be the molarity. Solve it quickly. Done. Now look, what is given? 30 gram of urea. That means given mass. Urea given mass. In short, you can write weight of urea, which is 30 gram. Now, what will be the molar mass of urea? M of urea, which represent molar mass of urea, which is basically 60 gram. Okay. Now, what will be the number of moles of urea? Number of moles. Number of moles you have to find. Okay. Number of moles you have to find. That means divided. You have to find number of moles. Number of moles you have to find. That means division. What is given? Given mass. So given mass to number of moles you have to divide it by molar mass. Okay. So just what will be the value of moles? Given mass, which is 30 gram, molar mass, which is 60. So number of moles should be 1 by 2. Now find out. First we are doing the molarity stuff. Molarity equals to number of moles of solute, volume of solution in liter. Number of moles is 1 by 2. Volume of solution, which is given 2 liter, divided by 2. That means we get 1 by 4. That means 0.25 m. M represents molarity. First question, what is the weight by volume percentage? Weight of solute. Weight of solute. Volume of solution into 100. Now weight of solute, which is 30 gram. Now gram is a CGS unit. So liter you have to convert it to ml. So that's why 2000 ml multiplied by 100. Now if you calculate this one, you get 3 by 2. That means 1.5. Weight by volume percent. Is it clear? Any doubt regarding this part? Tell me. Do you have any doubt? This stuff is clear? Okay. Okay. We are moving to the next part, which is molarity of dilution. Which is under molarity. Definitely which is under molarity. Now, what do you mean by molarity of the dilution? Suppose this one is a Solution. Solutions are present. Volume we are taking V1 and molarity we are taking M1. Now if you add some amount of water, after addition of water it becomes like this way. That means volume increases. If the volume increases, so what will be the final volume? Final volume becomes V2. Now if the volume increases, definitely molarity will be changed. Molarity, I am final molarity I am taking M. Now always remember, in this case, whatever total number of solute amount always fixed, because we are not adding any type of solute. So solute amount is fixed. Here also solute amount is fixed. Okay. Now if the solute amount is fixed, can I write number of moles? Here, what is number of moles? We all know that molarity equals to number of moles by volume in liters. So number of moles equals to molarity into volume. So can I write here number of moles V1 equals to M1? In this case, solute amount is fixed. If the solute amount is fixed, number of moles is fixed. So N equals to, we can write M2 V2. Now if you compare this to what will be the formula? Formula becomes M1 V1, M2 V2. Okay. Always remember, after dilution, volume increases. So after dilution, volume increases. If the volume increases, molarity always decreases. Okay. Is it clear? That is about molarity of dilution. Okay. Another thing, just write down M by 2 already discussed, which is 0.5, which is called as a semi-molar. Centimolar is given, or decimolar is given. Decimolar, which represent M by 10, that means 0.1. Centimolar is given, which is M by 100, that means 0.01. And millimolar is given. Which is M by 1000, that means 0.001. Okay. Is it clear? Okay. Now we are moving to the next part, which is molarity of mixing. Okay. Molarity of mixing. First, we are doing to molarity of mixing for non-reacting solution. When two solution mix each other, they are non-react. Okay. Now reacting solution means suppose this one is the acid, this one is the base. If you add these two, acid-base reaction takes place. These are reacting solutions. Okay. Now if this one is acid, this one is also acid. Now if you add these two solutions, acid can never react. So these are called non-reacting solution. Is it clear? Reacting solution, non-reacting solution. First one acid, second one base. If you mix them, so acid-base reactions takes place. These are called reacting solution. Non-reacting solution means this one acid, this one acid. When these two mix each other, so this one becomes non-reacting solution, because acid never gets reacted. So for non-reacting solution. Okay. Okay. In this case, solution is present. Here, M1 V1. M2 V2. Now when you add these two, after addition of this one, we get new volume. This volume becomes V1 plus V2 because they are non-reacting each other. Now in this case, we can write number of moles N1 which is equals to M1 V1. Here number of moles, just a minute, just change this one. Number of moles N1, number of moles of solute which is equals to M1 into V1. In this case, number of moles of solute which is equals to M2 into V2. Now in this case, what will be the number of moles of solute? That is N1 plus N2. So can I write N1 plus N2 which is equals to MR V1 V2. Now what is MR? MR represent resulting molarity of solution after mixing. Resulting molarity. Okay. Now we all know that N1 plus N2 which is equals to N1 plus N2. Now N1 is basically M1 V1. Can I write M1 V1? N2 equals to M2 V2. This one we can write MR equals to V1 plus V2. Now after getting calculation, what you get? The new equation MR which is equals to M1 V1 plus M2 V2 divided by V1 plus V2. Okay. Resultant molarity for non-reacting solution is like so. If more than, suppose 3 solutions are there, 3 solutions are mixed each other. All are non-reacting. Remember, all are non-reacting. What you get? MR which is equals to M1 V1, M2 V2, M3 V3, V1 plus V2 plus V3. Is it clear? Any doubt regarding this part? Tell me. Do you have any doubt? A non-reacting solution part is important for reacting solution case. Basically, these are mole concept chapter. Reacting solution we are not doing. Mole concept chapter for reacting solution. Limiting reagent concept is valid. In this case, no limiting reagent concept. But for reacting solution, reactions balanced reaction is required and limiting reagent concept is required. Any doubt regarding this part? Do you have any doubt? Just giving you one question. Just very easy question. Try to solve yourself. How much water should be added in 500 ml of semi-molar HCl solution to make it decimolar? Now basically, how can you solve? M1 value which is given M by 2, decimolar means M2 value which is given M by 10, and V1 which is 500. So can I write M1 V1 which is equals to M2 V2? So M1 value is basically M by 2 into 500, M2 M by 10 into V2. Now you should cut down this one. Just a minute, 500. So it becomes 2500 ml. So final volume is this one. Initial volume is 500 ml. So how much volume you have to add it? Volume added. Volume of water added, which is 2500 minus 500. That means 2000 ml or 2 liter water you have to add it. Okay, to make the solution semi-molar to decimolar. Any doubt regarding this part? Okay. Okay. So that is the end for today. Next class we will discuss later. Okay.
When you strive for excellence, you can't settle for mediocrity. So to succeed in any competitive exams, you need to have an expert mentor, best designed syllabus, test materials, and someone who cares for your career just like you. Welcome to Regis, where our programs are designed and executed by the IITians. Enroll your board now because we believe in nothing but the best.